So, I will discuss few things. Okay, the few questions were there. See, in generally for this part of the whole not course of the ideas, one is basically to develop models, find out the closed form solutions. One is to develop algorithms and find out the complexity, time complexity, space, and so on and so forth. And another is that if you do not find any closed form solutions, to develop multi-objective different type of heuristics. Carlos is more into the third part. I am in more in the first part. Algorithm design and checking the complexity is not my forte. This would be more of computer science and mathematics. Main thing is to basically formulate the problem from the application side, and if possible give closed form solutions for the proofs, which is in operation research parlance is much more acceptable in the publication and in journal publication and in work. If you are talking about problem formulation and they are trying to find out their usage using heuristic methods, that is a huge ball game also, because the problem it should be very intuitive, and based on that how you basically put that in the perspective of the heuristic methods is one area. So, technical I see in these three areas, and the third issue which I find, but this call you have to take as a researcher, as a person who is working, is that do not blindly take up any problem because it seems interesting. Take a problem which would definitely have some theoretical flavor plus a practical flavor. Publication is important, but do not go blindly for publication where you have to basically publish anything which has no shelf life, absolutely goes into the trash can. So, you have to make a choice accordingly and how you basically decide. Anyway, I will just try to wrap this up and then go into a topic which may seem simple to you, but at the fag end I will come why it is important from the optimization point of view. I am sure all of you know that concept of utility, preference theory. So, those you would be aware, but I will go a little bit fast and go into the concept of min-max theorem, safety first principle, then what type of loss functions are utilized, why the loss functions are utilized, their practical flavor, and how you model that. I started with initially the application side, then I will go into the, I am not saying through the theoretical side, basically to give you a flavor such that once you read it, once you get the interest, you can pick up from different books, because the net is flooded with different type of books in the market, different type of very fantastic websites are there, you can pick up those concepts from there. So, this to and fro, that once you read it and then pick up this would become much more smoother and much more easier for you. Okay. Now, another question was about publication. Publication I not going to comment here, it would be more on individual basis, because publication has to be a different ball game. So, what my area is definitely not in optimization, definitely not in heuristics. I am more of an engineer in statistics, theoretical statistics, but somehow you have to sell yourself. So, if I do statistics, no student will work under me. So, I have to basically change my one is I do my research in statistics, but in order to basically sell myself, market myself, I have to do that in order to survive. So, these are the work of some of those front. Some results which I will discuss later on, just I am not covering the whole gamut, I will just give you some flavors where you can definitely utilize these concepts accordingly. Okay. Now, the third problem I will go a little bit fast. So, it is almost same flavor. So, if you wait, let me check. Yes. The third and the subsequent problem, third problem is almost the similar as the second one, and the last one would be a little bit different. And the reason why I included it is that it is multi-objective, but it is a little bit different. It is considering probabilistic solution, and there are different techniques which are being nowadays utilized in the area of either single objective problem, non-linear problem, linear problem, multi-objective problem, which is in the domain of stochastic programming, reliability programming, robust programming, where the concept of non-deterministic parlance of how you model also comes into the picture. But obviously, you may ask that rather than going into a very generic framework, why didn't I go only in a very broader areas? So, the reason is very simple. I am not very comfortable to discuss areas where I have not worked and published, because it will give me much more comfort zone in order to discuss the problem, and basically hands on training gives me much better experience. Once you formulate the problem, solve it, and it either is published or you are comfortable with the results, it gives me much better comfort in order to explain to all of this. I will include other results, but main focus will be here. So, the third problem is also the maximization of the return over threshold value. So, you want your return to be greater than some threshold value, and you want to basically maximize the return, and obviously the risk minimization remains. Now, the risk minimization which I did discuss, there are different flavors of risk. So, one is the standard deviation, one is variance. You know variance and standard deviation from very simple statistics. One is basically the mod of the deviation, only taking the mod value of the deviations. So, you can have that. One is you weight the deviations, that you give some weightages. Weightages, why you weight the weightages, considering, I will give you a very simple example. Consider two cases. In case 1 you win 100 rupees, and in case 2 you lose 100 rupees, right. So, in general parlance, if I ask you a question that your level of satisfaction or dissatisfaction for winning 100 rupees and losing 100 rupees, is it the same? Answer is technically should not never be the same, because what I win and what I lose are of two different consequences to me. To give you a very simple example, let me pick up a volunteer, and who is there who likes sweets? Sweets, laddu, rasgulla, something. Somebody likes that. Let me. It is not. You don't have to come to the dais. You can at least tell me if you like sweets, and then I can ask you a few questions. Okay. So, consider that in the early morning you are very hungry, and then I give you consider any sweets like laddus. So, you have seen Chhota Bheem, right? So, I give you one, you consume it, second you consume it. So, whenever you are consuming any goods, or whenever you are taking goods and trying to invest, trying to basically optimize, you always want to find out what is the marginal rate of increase of the value which you have, right. You want to get positive benefit. So, technically the positive benefit we always consider is increasing at some rate, increasing at an increasing rate, increasing at a fixed rate, or increasing at decreasing rate. Those are different questions. So, but if I keep asking you a question after the third, fourth, fifth, sixth, at some point of time you will definitely say no. You will stop, you would not consume that good, or would not like to basically invest, or would not like to have that particular product. Practically we will consider that to be true, but in the theoretical sense we always consider the more I give you, more you want, right, which is a very theoretical perspective, but it gives us good results. Like if I give you more money, obviously you will ask for more money, because you want to get the benefit for that. Now, in the same parlance, when I go into the concept of variance, so if you consider the formula of variance, what is that? Is basically the square of the deviations, sum them up, and then solve the problem, which is the second moment. Now, consider a very simple example. An example is like, so now if you consider the variance, what do? If it is, and if you are trying to estimate, you know what is the simple English word of estimation. You have some value which you do not know, and you pick up a small sample, and then from the sample you try to basically estimate or forecast that value. Now, when you want to estimate or forecast the value, what you want to do? You want to put some weights. So, if you consider the variance part, you equally penalize the weights. That means, if it is actual value is 2 and the predicted value is 4 or 0, in both the cases the difference in the prediction is +2 and -2. So, if we square them considering the concept of variance, they are both in the both cases 4. Theoretically is very nice, because when you are trying to minimize the variance, it's basically you are trying to minimize the second deviation or the second moment. Why the reason is like this? For any I will come to that later on very briefly. All human beings, the example which you are considering, the consumptions, we consider that all human beings have quadratic utility functions. I will come to the utility functions later on, and there is a one-to-one similarity between quadratic utility functions and normal distributions, because the returns of investment, if you have a quadratic utility functions, always results into normal distribution and vice versa. There is a one-to-one relationship to that. So, when you want to basically find out the variance of your quadratic utility functions, it exactly means that you are trying to minimize your variance from the normal distribution. So, those two go hand in hand, so hence we are able to solve our problem. Now, practical sense, things are different. So, obviously, the slides which you are going to consider now would not give you that example. I will come to that later on, but let me give you that example now. How many of you are okay, let me give you a very simple example. Consider a dam, and the dam actual height should be basically 120 feet. So, if it is 120 feet, so basically you will basically invest your material, man hours, material cost and all these things accordingly. So, consider two cases. In case 1, the dam is built to a height of 122 feet, and in the second case it is built to a height of 118 feet. So, in both the cases the difference is +2 and -2. So, if we consider the case of, say for example, the net worth of prediction, over prediction, under prediction which you do, we will find the overall prediction, non prediction, over prediction, under prediction is in both the cases 4, 2 square minus 2 square. Now, think on the practical sense, does it really make sense to consider the variance as the best predictor of trying to find out that what would be the total loss? Consider case 1, height is 122 feet. What is the overall initial cost? It is man hours, materials, time. You have spent some extra amount of money with respect to case 1 where the height was 118 feet. Consider the scenario is changing, flood comes. So, the probability or the propensity of the flood breaching the dam is much higher in the second case than in the first case, when it is 118 and then 120. So, the overall catastrophic loss which you will face in the second case would be much higher than the first case, which means the total cost which you are trying to find out in this case, considering the variance, would not give you the right picture, which means underestimation is more penalized than overestimation. Underestimation means 120 versus 118, 120 versus 122. Does it make sense? Now, consider, so in this case underestimation is more penalized. Consider the other example of where overestimation is more penalized, and this is very heavily used nowadays in utility function, trying to find out the investment, trying to find out what is the best design of a car and so on and so forth. Consider that you have an electrical circuit, and we know in our houses you have the fuses, right. So, the fuse is basically a trip switch. If the electrical voltage is more than that, then it trips, and then you change the, initially those were the copper wires which you basically change, now those are the just the switches which you have to just plug in. Now, those in big electrical circuits you have the vacuum circuit breakers. So, they operate on the principle where if the voltage fluctuation is too high, they just trip. Now, consider there is a machine and the vacuum circuit breakers warranty life or the average life of working is 6 months. So, you as an engineer or you as a marketing manager, whatever, you have two cases in front of you, or you predict two cases. In one case, the average life if you say is, say for example 7 months, and another case the average life which you say warranty life is 5 months. So, what does warranty life means? That means after that time period you will shut down the machine, work, maintenance, and then start the work. So, consider the first case when it is 7 months. What will do? That the machine will continue working till the 6th month and beyond. So, you will get extra production, which is nice. And in the second case, what you will do? You will stop the machine at the 5th month, repair it, and then start again. So, which is loss hour, man hours loss, and production loss. But think from the other side, the probability, the propensity of the first time, which is 7 months, the machine failing is much higher than in the second case. So, if there is a catastrophic loss, the huge amount of human life loss, material loss, and a fire hazard, whatever, is much more when it is 7 months than when it is 5 months. Clear? So, in this case, you are more tempted to underestimate the warranty life than in the former case we are more tempted to overestimate the former life. So, these type of loss functions, these type of unequalized asymmetric loss functions, asymmetric utilities are very heavily used in trying to take decisions where unequal penalties are of huge consequences. I will come to those problems later on, but let me at least start off. So, in general, whenever you are trying to formulate a problem either in finance or in economics or in many mechanical design, electrical design, you will try to find out what is the utility of the net worth which you get. So, based on that we formulate few problems. I am not saying that whole lot, but we do that and then try to basically solve the problem. I will come to that later on. So, in this problem we try to basically calculate the overall excess of the returns over a stipulated value, and then basically you have the risk. And the risk perception, when you consider different type of utility functions, is not always true that you will have variance as the best risk, because in generally we know that we always know that a statement is there in English that do not put all your eggs in the same basket. That means you want to basically diversify the risk, whether in project management, in civil engineering, whether in investment, whether you are trying to basically build up a factory, whether you are trying to build up a car, whatever it is. The general perception is where, because if you are able to diversify the risk, then any loss you make on any one front is basically compensated by the gains on the other front. So, your overall return and risk are basically at a average level. When you are considering the normal distribution, that is true, and all the calculations are true, because you consider utility to be quadratic, because variance is the best measure of the risk. But the example which I gave for those other loss functions, which I will mention the name later on, in those cases trying to find out the risk using the concept of variance is not always true. The reason is very simple. When you consider the normal distribution, think about the normal distribution. You are aware what is mode, median, and mean? So, consider the normal distribution, the mode, median, mean are at the same point. But consider if it is asymmetric, whether shifted onto the left or to the right, we are more tempted to use the median as a better measure of the central tendency rather than the mean, because mode gives you that 50% is below, 50% is above. Now, if you shift your attention to trying to find out the variance, variance calculation is what? Expected value of x minus E of x. E of x is the mean value. So, many of the cases trying to find out the variances with respect to the mean value may not give you the right answer what is the dispersion, because variance is a dispersion. So, many of the calculations which we do trying to find out the variance with respect to the mode would give us much better results. Because if you see the many of the median, sorry, not the mode, median would give us the better results, because median would basically be that value which basically differentiates the overall distribution into two equal portions, 50% below, 50% above. So, in other type of distributions which we consider, like if they are not normal, then trying to find out the variance using the mean value is not the right answer. You use the basically the median, point 1. Point number 2, there are other type of risk measures also which are very heavily used nowadays in engineering and in other types of, say for example, investments. Those are in the finance parlance, I will give you the word, they are known as conditional value at risk, that what is the risk value depending on some certain set values which you have already set for yourself, or there are value at risk, so on and so forth. So those are utilized, say for example, in mechanical design, in supply chain management, in finance, in order to find out what is the overall risk. I will come to that later on with one example in this class today, and then come into the utility theory later on. So let me go. What I am giving you is basically a bigger picture and how it fits in the overall discussion. Here again the constraints are very simple. Constraints are that your returns are for one time period to the next time period should always be greater than the initial investment, if you see the first constraint. The second and the third are exactly the same. The returns is greater than RP star value or the fixed value which you have set for yourself, and the third is very simple, and the sum of the investment should be equal to 1. And also the weights are between 0 and 1, or whether you go for this short selling, not short selling, they can be combined accordingly, but I have not considered them in the problem. So again, if you okay, by the way, when I started the initial class, this second part after the tea break, I did mention that general focus would be either on trying to find out the exact solution, trying to find out the algorithm and the complexity, and trying to find out the best performance algorithms or the heuristics. If you ask if the question is asked that whether I utilized the NSGA 2 or I try to utilize taboo search and try to compare them, the results from the metaheuristic point of view, my answer is no, I have not done it. I have not checked their time, I have not checked their CPU usage, I have not checked out what is the efficiency of the results, how asymptotically how they converge to the mean value as fast as possible. My answer is no, I have not done it. If you are asking the question from trying to find out the complexity, no. If you are trying to ask the question from the algorithm design, yes, I have done something. The main focus is trying to basically build up the theoretical result, find out the closed form solutions. If closed form solutions are not there, at least give some asymptotic results and then try to utilize them for the metaheuristic techniques. So the path is like this, not concentrating only on the algorithm design and the metaheuristic techniques. So here also, again, from the practical sense, you do the like in the time series forecasting or the time series regressions which you do, you again do a block bootstrap, generate it B number of times. Capital B can be anything depending on the efficiency on the problem, and then you find out the averages of the averages and then plot it. So the plotting of the problems are exactly the same way which you would expect on the risk return framework, is basically the overall utility curve which you should get. Like this, like given an example, there are, I am sure you are aware of very simple economic perspective, from which you can find out that what does the concept of Pareto optimality in the curve gives. Consider there are two products and both are complementary to each other, like tea and coffee. So if the prices of tea increases, others should decrease because the consumption should be fixed, and vice versa. So if you plot those graphs, the prices and the quantity, they basically are an inverted curve. So in the same way, when you are trying to basically plot out the risk and the risk and return go hand in hand. That means more risk would be more commensurate return, or vice versa. But obviously the risk and return would always be a diminishing one, because the more returns basically comes, risk also increases, but the perception of risk basically starts to basically increase at a decreasing rate, because more I invest, more you basically put your money in any investment, I want a return, but my overall quantum of return, the example which I gave to her is that I will ask for more, but my propensity of trying to utilize that goods or utilize that particular value would basically start decreasing. That means initially if I had 2 sweets, then the next stage it will be 1.5 sweets, then it will be 1 sweet. So that means at the end of the day it will almost marginal rates will go to 0. So if you check those graphs, actually they become almost parallel to whatever the risk value you increase, people would not be willing to invest in any more returns, because they know that their optimum value is that. after which value they would not invest. So, if you are concentrating on the risk and return framework, they almost look like this. Whether they are increasing at an increasing rate or increasing at a decreasing rate, that would basically be dictated by the returns which you are going to get from the different type of investments which you have. This is some of the threshold or the returns, this investment value with respect to the returns. Again, if you concentrate, if you check your slides later on, so the combinations of different stocks are changing at different random rates, and in the end, the overall consumption of the returns basically is subsumed by only one stock. Obviously, there would be some economic implications for that, but I have not analyzed that. I just wanted to show you the results of the returns based on which you can make a decision whether you want to invest or not invest. Again, this is a very simple Pareto optimal curve which gives you the two functions which I had. Functions were basically the threshold value of the returns and the risk. Now, the questions you can ask that rather than take the risk in the normal case, can we take any other measure of risk? The answer is yes, considering either you want to take the conditional value at risk or the value at risk or the expected regret. I am using some words which are generally used in different type of utility analysis, or the expected shortfall, or excuse me, or I am trying to basically find out the norm of the deviation of the risk, or I am trying to find out the variance with respect to the median. So, all these things can be done, and they would definitely give you the same type of results which I have discussed. So, obviously, it would mean that as risk increases, whatever the risk is, the return should also increase, but at different rates, such that as the risk and the return increases, then the marginal rates basically tends towards 0. Okay. Now, this is one work, and this I am again going to discuss this more from the optimization point of view, and also from the point of view of the using the algorithm. I am not going to discuss from the point of view of the algorithm design. This was utilized in MATLAB, and there are many different library packages in MATLAB which you can get in the net. One was, which I remember correctly, was basically a robust optimization add-ons links, which is known as ROME, ROME. You can find it in the net, and that uses a huge amount of stochastic optimization, which can be used as a library functions for the MATLAB. ROME. I don't have the link. I can give you the link later on. So, to give a very brief background, this was worked by one of my students, Rakesh, and this was basically a probabilistic problem where we had an objective function which was multi-objective. Two objectives were there, but the solution technique which we used was more stochastic in nature rather than deterministic. And obviously, the tools which we used was genetic algorithm. The reason is very simple, that NHGA2 is a time tested one. We have the codes, you can basically utilize according to your own problem formulation. Obviously, didn't compare with other heuristic, because that was not our aim. Our aim was to basically to get some solution based on the theoretical results which you have been able to prove. The problem formulation is again the same thing. You have some stocks, you have some time frame, that then the shifting window concept, everything is the same, and the weights are given, the nominal values are given, the number of stocks n is given, time period is given, and then the value at risk is given. So, why I am skipping is that maximum the nomenclature is exactly the same with respect to the other three problems. Only difference what is that, I will come to that later on once I discuss the problem formulation. The problem formulation is like this. It is not complicated, but basically I am trying to put some weights on the objective functions and try to find out. Now, what is interesting is what is interesting is that the constraints are probabilistic in nature, and as I discussed that for the normality case, trying to solve the constraints, if they are normal distribution, is very simple. You use the normality, that the probability of x less than equal to x, you convert it into a standard normal and solve the problem. Now, that is true and that is possible if your distribution of the returns are normal, but life is not that simple. We considered the distribution for the first time after the 3 models, the first time we considered distributions are not normal. And there is a huge body of literature which is there, where different models have been developed either in finance or in mechanical engineering, especially in civil engineering, in different areas of trying to basically find out propagation of pollutants through rivers, where they use the concept of extreme values. So, extreme values like this: if a shock wave happens, if an earthquake happens, and the shock propagations, if you know, there is an epicenter from where the shock wave goes. So, the overall destruction in and around nearer to the shock waves are much heavier, and as it propagates, it gets intensity decreases. So, obviously, the overall effect for the shock waves as you go further away from the epicenter decreases. So, how do you basically consider that? How do you model that? So, and you want to find out what is the probability of failure, because based on that, if you have an insurance, I am giving an example, if you have an insurance and the shock waves or the tsunamis have occurred in, say for example, some part of Pacific Ocean and it is going to affect Japan. So, how does the insurance company basically try to find out what is the overall effect and the loss? Like when you buy a car or if you have a health insurance, so that depends on what? What is the age of the car, what is your health, whether you have any disease. So, based on that the premiums are decided, right, depreciations and all these things are considered. So, in this case the extreme value distributions considers where standard deviation is no more the best risk measure. It is done by the formulation which is known as conditional value at risk. Conditional value at risk means conditions on some fact, that how do you find out the overall risk, which perception which you are trying to find out. So, if you try to basically model it and if you try to visualize it, the visualization is very simple like this. I am going to draw it for the normal distribution. It can be done for the multi-normal, considering normal distribution can basically go into the multi-normal phase, but for extreme value it becomes difficult. You have to use different type of bootstrap method, different type of simulation method to try that. I will just try it for the normal distribution case. Consider this is the normal distribution and you want to basically put up some risk value. Consider the risk value is alpha, right, the probability of failure being greater than alpha, less than alpha, whatever it is. Now, consider if this is the loss function, you are not interested on the risk which is happening on the left hand side. You are more interested to find out what is the overall risk or overall perception of the value of loss which you face, which is on the extreme right. So, the best way to find out is that if you are able to find out the so called center of gravity of this whole covered hashed area, so lesser this value is more onto the left, better for you because there is less loss. More this value on the right, it is basically more loss for you. So, this is basically known as conditional value at risk, where if it is a normal distribution, trying to find out the average value is very simple, because what you will do, given consider this value of this is alpha and this value is, say for example, x alpha, because corresponding to some alpha value you will have a value of x, right, from the standard normal table. Now, what you want to find out is the average value distribution, which is for x of f of x dx, where 3 things are important. Number 1, this x value is always greater than x alpha, because you are trying to find out the area on the right hand side. F of x is not the distribution of the normal distribution, it is the distribution of this area which is onto the right hand side. For the normal distribution case, it is very simple because you know the normal distribution and solve it. But for non-normal distribution, trying to find out what is the distribution onto the right hand side of that alpha becomes very difficult, because if it is skewed to the right, skewed to the left, trying to find out there are different techniques which are there in simulation. So, one is very big one is the bootstrap method and block bootstrap method, then jackknife and so on and so forth. So, those are a part of statistics which are very heavily used. Here we use that, but obviously that this would definitely are simulated results, they are not exact solutions. So, let me give you a warning beforehand. So, conditional value at risk is being utilized for the first time, where I want to find out conditional value at risk is basically the less than sign which you have C var value for the loss value based on the fact that you want to find out the losses considering they are no longer normal, they are non-normal. So, based on the case, like whatever stock you are taking, whatever different type of portfolio you are taking, whatever different flows you are taking, you have to basically pick up that distribution, whether it is generalized Pareto distribution, whether it is Gumbel distribution, whether it is Frecker's distribution, whatever it is gamma distribution, you have to pick up the distribution, find out its parameters. So, in general any distribution there are 3 parameters: location, shape, size, scale, so location, shape and scale. So, alpha, beta, gamma these values. So, you want to basically generate them. The generation needs a lot of statistical tools like the ones which I discussed, the block bootstrap and so on and so forth. So, based on that we generate all the 3 alpha, beta, gammas. This alpha, beta, gamma is, this alpha is not the same one which I am talking about. Alpha, beta, gamma is basically the shape, scale and the location for the distribution. Generate that, and using that generation you basically now pick up a set of values which you have simulated. From the simulated, what you do is that you basically, I am just mentioning the steps. You generate the values of alpha, beta, gamma and generate a whole set of data points, right. Once you generate the whole set of data points, you basically put them from the least to the highest, the least to the maximum value. So, once you put them in the ascending order, what you do is that you pick up, consider the alpha value is 95%, which means what you will pick up, you will count the total number of readings and take the 95th percentile of that value, pick that value which would basically give me the conditional value at risk average value, put it down and note down and run it, say for example the first time. Once you run it the first time, you will get some weights, because the output of the weights for this total simulation run is basically the weights of the stocks. When you basically have the weights of the stock, again you simulate it, initial set, find out the 95th percentile, because the alpha value is not changing, again find out the weights. When you keep simulating it, you will get different type of weights. The average of each weight would basically give you the average of the investment which you are trying to do in each of the stock. Based on that you would formulate the portfolio. This is not the exact solution. Based on that you formulate the portfolio and basically invest in that stock for the next time period. When you go to the next time period, again you simulate and proceed accordingly. Now your question would be that how do I consider your risk perception and my risk perception? They are done in 2 ways along with the market. If you see these values, this conditional value at risk which I have drawn, this alpha value is market driven. That means market would say that what is the overall perception risk which is going into each and particular stock. So, consider that is 20% or 95%, but you will also have a propensity to basically believe it or disbelieve it. That belief factor would come from the value of beta 1 which is there for each and every formulation. So, is beta 1 is basically 20% for you and beta 1 is 35% for me. What I am doing is that I am trying to analyze the market risk from my side also. So, one is the alpha value of the market risk, one is the beta for the market risk which is perceived from my side, which is the personal investor risk. So, based on that, when I combine, I will have different envelopes which will give me the best plan of action, what is the overall risk and the return of the portfolio. So, once we have these values, I am not going to the solution, because those solutions are theoretically a little bit cumbersome, leave that. So, once I solve that using mathematics for this, and when I find out the results and try to plot them depending on the different type of risk values for both for the market as well as for the individual, the results are, I will just report, they have been done for the Australian one, the Brazilian market, the French market. I am only taking the market values, not individual risk as such, they are the market risk which I have. The German DAX, the FTSE which is from UK, the Canadian one, the Hang Seng which is the Hong Kong, the Argentinian one, the Nikkei for Japan, NSE, which is the counterpart for BSE in India, New York Stock Exchange, not the Dow Jones Industrial Average, and the Singapore one, which is the STR SGX. So once I do that, again same thing, I take 10 years data from 2000 to 2000, for 10 years from 2000 to 2010, again which is total of 2840 trading days, again block bootstrap, break them into windows, shifting windows, whatever it, and then I find out the values. I am not going to report these values, these are of no consequence for all of us, but check these. Yes, it is a little bit difficult to summarize here, but I will explain it here. So these are like corresponding envelopes. So if you see in a 2-dimension one, they look like Pareto optimality curves for 2-dimension. So if you see the blue one, green one, red one, and light blue one, they are the envelopes. In this room, consider there are envelopes like tents which have been placed one over the other, and they are concentrating rings, they do not cut each other. So that means if you drop from any one point, or the blue or the green or the red, it will give you 3 factors for each points. One is the return, one is CVAR, which is the conditional value at risk, and one is the VAR, which is the value at risk. Value at risk would be dictated by the market. Conditional value at risk would be dictated by a combination of your side and the risk also, and the return will be dictated from your side. So that means you are trying to basically consider both the risk from the market plus the risk from your side plus the return which you will get. For each level of risk and return, you are able to basically plot these 4 or 5 or 6 concentrated curves depending on what is the combination which you have. I am saying that if you want a discussion, I can hand over the codes, but discussion of the codes or the algorithms are not my concern. I want to basically make a point that these different type of problems, if you are able to solve them theoretically, obviously you want a practical answer. Solving them using some Metaheuristics techniques or heuristic methods is what you get. If you want to compare them, that is a different ball game. You can definitely do that. If you ask me, I have not done it. You can definitely consider that. And if you are trying to basically compare the algorithm design and the complexity, that is a different task. So what Carlos was discussing was more from the heuristic methods. Mine probably is more from the operation itself method. And for the GA formulations and how you solve it would basically be discussed more in details by Jose tomorrow. Tomorrow I think he will take the class accordingly. So these are, if you pay attention to these beta values, basically these beta values are a combination of the risk which you have. So if you see these beta 1 and beta 2 combinations for alpha 0, it means the market risk at 90%, what are your different risk percentages which you have. Market risk being 90, your being 90, that means it will be the blue one. Market risk being 90, your risk being 95 would be the green one. Market risk being 90, your risk being 97 would be the red one, and market risk being 90, your risk being 99 would be the light blue one. So again, if you change this with these 4 combinations, you will get different curves. So some of the curves are like this. They are non-overlapping. Remember that they are. If you are able to turn this graph, you would basically be able to find out. So if you are looking at this direction, from this direction, considering that only 2-dimensional view is there, or from this direction, you will find out the envelopes according to the Pareto optimality, whatever it is. So market risk is basically 90%. You have different combinations. This is for most probably for a second stock. Okay, I will tell you. The first one, was for the Australian one, next one was the Brazilian one, and so on and so forth. So if you consider the market risk for in sample and out sample for the Australian one, out sample and in sample, why I consider it is very simple. In statistics, what you want to, or for the robustness of the problem, whatever problem model you find out, you basically test it for a in sample, means the sample from which I am trying to basically generate the parameters alpha, beta, gamma. And then once the problem formulation is done, when I get the result, I try to basically test it that what is the outsample data information such that I can say about the sensitivity of the model, robustness of the model, because I have to basically predict that how good or bad my prediction is, based on which I am able to conclude. So, these are some of the results which are there for the out sample, in sample. This is again for 95%. For the Australian data, for considering all my 4 level of risk, 90%, 95%, 97 and 99%. Then I have, this is for the in sample part. Again I have for the out sample part 90, 95, 97, 99, again with a level of 95%, and then I basically do it for all different 4 combinations. 4 different values of market risk, 4 different level of investor risk. It can be increased to different levels of complications also, depending on how you are doing. Only one thing, if you are somebody is talking about whether these can be done for multi-objective of more than 3 and more objective function, yes, it can be. But what models you use, how you solve the problem, that has to be specific to the model formulation and how you solve it. Those have to, and then how you compare the results, do the analysis. So, those are different parts of the discussions.
So, basically the CVAR is used to find out the average of losses
on extremes. If you see the distribution, average of the losses would basically be coming from the mean value of the losses. But that is not my concern. I want to find out the extreme losses. Right? Because more loss I make is going to basically have a devastating effect on my investment or my consequences. So, I want to find out what is the probability or the propensity of the losses happening on the extremes. So, rather than taking up one value, I take up the average of the extremes. So, CVAR is basically the average of the extremes depending on the, see, this is the market loss. So, market loss I know, I can sustain. But what I am more interested in is what if the loss exceeds the market. If it exceeds the market, I would basically try to find an average value. So, if the average value is known to me, then I can basically make my decision. Yes, the average value of the extreme losses are, say for example, 20% more than the market loss. Will I be able to sustain that? Based on that, I do my calculation. Because now my set of information is now being tempered by my level of risk plus the market risk. Because market risk everybody would have, right? If you are investors, if you are basically making, everybody has the same set of information. But how you analyze the problem, or how I analyze the problem, or how does a third investor analyze the problem, would depend on his or her own perception of market risk. Whether that is good or bad would depend on that person only, not for me. But how I see the problem is totally different from how you see the problem. So, level of average value on the right hand side is being dictated by the market risk and my risk. Market risk is basically given by, I am using the variable as alpha, and my risk is basically beta. So, I combine them to find out the overall risk. So, these are the different combinations which I have. So, this has been published, so I am confident enough about the authenticity and the result values here. I will just discuss one thing. I will start one small topic, keep it very brief, and then go into the applications later on. So, I am sure all of you are aware of that, but still, okay, I will start with a very simple example. Okay, let me ask a very simple game. Consider there are 2 rooms, and in one room there is 100 rupees, and for 100, I am not mentioning the rupees, because rupees would basically make the discussion more complicated. There is a 100 unit, and to enter the room you pay 100 unit. Once you pay 100 unit, open the room and get 100 unit. And in the other room, you there are 2 boxes. Again, you pay 100 unit, and the 2 boxes are based on a coin, unbiased coin, half. You pay 100 when you open one box with the head. If it head comes, you open the box, it's 0 unit. And if you open the other box, it is 200 units. So imagine the scenario. For 100, you get 100. In another room, you get, for 100, you get either 0 or 200, right? Now I ask any one of you, which room would you basically prefer, the first or the second? First, no second. How many are undecided? No, it's fine. Let me increase the stake. Where 100 becomes 1000. So 1000, 1000, 2000. Right? Are you willing to change your decision from the second room to the first room? How many are still sticking to the first? First case, that means once you decide second room where there are 2 outcomes, you will still stick to that. Let me increase to 10,000, 20,000, 30,000. As I am changing that 1000, so the values are also changing correspondingly. 30,000 means 30,000 to enter, 30,000 on the table, on the room 30,000, 0 and 60,000. Increase to 1 lakh, 2 lakh, 3 lakh. At one point of time, all will change. Everybody will change, I can guarantee that. So now the perception comes in that how you analyze the risk or you analyze the outcome. So when you analyze the outcome, there are different classes of human beings. And the classes of human beings are based on the factor of risk. Now risk can be either single function or multi-functions. It can be either vector or a scalar, depending on different type of decisions which you have. Now, there are basically 4 levels of risk, 4 types of investments or utilities. Let me use the word utility. Generally, one is quadratic, which is very simple to understand because it has got a one-to-one correspondence with normal distribution. Your normal distribution is low, life is very normal for us, so utility is also quadratic. Others are exponential, which are there in the slides. I'll come to that. One is logarithmic, and one is power utility functions, right? So in all these cases, whenever, and in general, that Carlos did mention very clearly that whenever you're making an objective function and trying to optimize, the general optimization problem basically started from economics. He did mention the problem of Koopmans and how the transportation problems. He did mention the name of Koopmans. I did see that. Basically, you have some resources. Some utilization of the resources have been done to get some output. So whenever if you are trying to basically utilize the resources, there is positive and negative also. Positive is basically you are trying to maximize the expected value, and negative is basically trying to minimize the variances or the second moment. So utility would basically try to concentrate on the first moment, which is expected value, and the second moment, which basically the concept of variance. And all the problems which are formalized in operation research are these only. So you have some resources, you are trying to basically utilize those resources in order to basically find out the best outcome. Now, in general, many of the problems which we discuss, which I will discuss maybe not tomorrow or day after tomorrow, is there are non-parametric in nature. Now, non-parametric in nature, like I am sure all of you have heard of these type of problems. There is the concept of methods of analytical hierarchy process, which is used AHP, ANP is used in analytical network process, Topsis method is there, Electra method is there, Macbeth method is there. Macbeth is not the Shakespearean one story, this is the Macbeth is the method which is used. So in all these things which you have is that many of the decision variables are not quantitative, they are very qualitative. So again, coming back to an example, you want to buy a car, right? So, your decision, I will give you my example which is absolutely true, that when I purchased the car, none of the decisions were on my favor. So, basically whoever decided that, and do not divulge the story outside. So, when you are making a decision to buy a car, consider there are 4 members in the family, husband, wife and 2 kids, right. So, initially, and if your choice sets are very huge, then the decision of buying to buy such thing like either a fridge or a TV or a car does not depend only on the price. It depends on what is the make, what is the resale value, what is the EMI you have to pay, what is the seating space, what is the luggage space, what is the color of the car, how good or bad it looks like. So, there are different qualitative as well as quantitative values to that. So, apart from the cost. So, if it is color, obviously it is not possible to quantify it, whether red color is good or black color is good or the white or green, you do not know. If the safety is a principle, yes, it is very important, but you cannot quantify safety also. If luggage space is important, you do not know whether luggage space is good, huge amount of space or less amount of space is important, you do not know. But it comes to the maintenance, yes, I know it can be quantified. If it is EMI which I have to pay per month, yes, I know it is the EMI factor which is there. So, in this many processes, when you try to analyze the problems, this quantitative and qualitative methods of attributes and variables have to be combined. So, whenever you are trying to basically combine them, you use this concept of utilities which I mentioned, where you want to find out some distance functions. So, distance functions can be either the L, you are aware of the L1 norm, L2 norm, L infinity norm, which is the Manhattan norm, the L2 norm which is the Cartesian one, infinity norm. So, use different type of norms of distance. So, the norms of distance can be classified into 2 parts. One is how close am I to the best possible solution, and farther am I to the worst possible solution. So, I basically try to find out either the average or the median weight or weighted distances, and then try to basically do the problems. So, the class of problems which we will discuss later on, this MAGMED method, Topsis method, Electra method, and all these things basically are based on 3 factors. Number 1, what is type of utility which I have? Utility means what is the net value which I have. So, net value what you have for yourself and what I have for myself are totally different. Number 2 case is that when I try to basically combine these, the qualitative and attributes and the variables, the total weights which I give would also be different. So, say for example, color for you is important, color for me is not important. For you the resale value is important, for me the resale value is not important. I am talking about the car. So, all these values or the weights which I give will also be dependent on the human being, which is not specific to the utility only. And the third part is that when you combine the attributes and the variables, how you rank them, ranking system is also different. In the sense that, say for example, why the ranking system is important is, if the example which I try to give is that if I win 100 rupees and I lose 100 rupees, the propensity of the happiness or the sadness which I have of winning 100 and losing 100 is different for different persons. So, if I win 100 rupees and I lose 100 rupees, I may be of the same disposition, I am equally unhappy or unhappy. But in human beings it is found, and think what I am saying that may not make sense to you, but think, see for example, if there are 2 decision making, and when I am basically making a decision where I lose some and somebody else's gains. So, my overall perception of the loss and gain would depend on what is my overall perception of risk. So, if say for example, if 2 persons are there, he is doing very well, I am not doing well. In another case, I am doing well and he is not doing well, the level of dissatisfaction and satisfaction will be different. If I am doing well, he is not doing well, that means if I am okay, he is not okay, I am happy. But if he is okay and I am not okay, my level of unhappiness is very high. So, how you basically quantify that, basically this is a very practical problem, and how you quantify that basically comes from the perception of the risk, which cannot be quantified from the point of view of variance, because variance is the dispersion, right. And when the concept of variance is taken in the picture, positive and negative effect are being equally penalized. This may not be possible when you are trying to do that. So, I will consider those problems later on after going to the concept of utility functions, and most probably not tomorrow, day after tomorrow I will handle it. So, let Carlos and let Jose take the, what is Jose's plan, let me talk to him. Once he takes that, you can basically do it accordingly. And so with this I will close this class today.